Hi everyone, we're going to start off by pulling out pages 398 through 400 and we're going to start looking at lesson 27-2, factoring with ax squared plus bx plus c, where our a value is actually going to be not equal to 1. I know we showed how to use the area models before and how to do this, but I'm going to show you another method. It's going to be called grouping, and this is actually my favorite method of any type of factoring. You can really use it on any type of problem that we've done so far. I wanted to save it for last just so you can kind of see all the different types of ways that we've gone through before with the special products, with the GCF and whatnot, but that's what we're going to be focusing on today. We're going to go ahead and look at our learning targets. The first one is we're going to learn how to factor trinomials of the form ax squared plus bx plus c when our GCF is 1. So we're going to learn, okay, well, do I need to divide out a GCF before I do this problem? Or we're going to look at our second bullet point where we're going to do the same thing. We're going to factor those, but we have to take out a greatest common factor first. That's probably going to happen on our third page of notes, but our first 2 pages of notes, we're just going to look at how to factor by this method of grouping. So in the margin of the page, I wrote a warm-up problem that I'm going to have you do. Now, this is going to tie into exactly what we're doing today, and it's a review of what we've seen before. But our warm-up problem is we're going to use the distributive property to multiply the following 2 binomials. Well, we've seen how to do these types of problems before. This is kind of our favorite style. Now, some of you, I know you like to use the area models, but I'm specifically asking you to use the distributive property right here. So let's review this idea. We take our first binomial and we can break it up into its 2 terms. And then we're going to go ahead and we're going to give each of those terms the second binomial. Now, when I say give, that means we're going to multiply each of those terms by that second binomial. Okay, we know the drill. We can distribute 2x times x is 2x squared. We distribute 2x times 2, that's going to be plus 4x. We're going to do the same over here. 3 times x is 3x. And then finally, 3 times 2 is 6. Lo and behold, we notice that we have like terms, 4x plus 3x. We can add those together. So we get 2x squared plus 7x plus 6. Boom, that's our answer. So we saw how to go from this part up here and how to distribute and multiply to get that trinomial. Now, what's really cool is what we're going to learn how to do is we're going to learn how to do this process in reverse. So that's going to be called by grouping, and we're going to understand what we're doing and why we're doing it. And it's actually going to match up with the steps miraculously. So very interesting. We're now going to go back to and refer to the problem the textbook is giving us. So we're going to go ahead and start looking at this problem and reading through it. All right, so starting up here, custom showrooms now wants factory steel buildings to create a floor plan with more than 1 great room. Instead, custom showroom wants 2 great rooms, 7 large offices, and 6 cubicles. And they're going to signify this trinomial of 2x squared plus 7x plus 6. And we're going to try to figure out how to factor it to determine the length and the width of the entire office space. Okay, awesome. That's looking good. Well, we're going to look at and see, okay, how this example, they show us right here, how we're able to factor it. Now, here's what I'm going to tell you. It says to use a guess and check method. I do not want you doing that. That is not the best way to approach it. Honestly, I feel like it's a little bit of a time waster to go through every single situation on how to come up with those 2 binomials being multiplied together. So we're going to look at this from a different perspective of grouping. Let's say we're looking at example A where we have the trinomial 2x squared plus 7x plus 6. I'm going to have us go ahead and in the margin we're going to start putting example A and we're going to talk through how to do grouping. So let's write down 2x squared plus 7x plus 6. Well, thinking about this from our usual approach, to help us figure out what pieces we're going to start to break this up into, we're looking at the pattern of what multiplies to a times c but adds to b. We're still following through on that from before, using that organizer to help us out. So what multiplies to 12, because that's 2 times 6, and adds to 7. So multiplies to 12, adds to 7. Hey, that's going to be 3 and 4. Now the 3 and the 4, remember they multiply to 12 but add to 7. So let's look at our 7x there, that guy right there. What we're going to do is we're going to replace the 7x with a 3x and a 4x from our problem right up there. So we're going to rewrite the first term as the same, 2x squared, and we're going to rewrite the last term as the same. But the two middle terms, instead of 7x, we're going to put 3x and 4x. Now, honestly, it doesn't matter the order of either of them. You could put, one before the other. It doesn't matter. I mean, I could put 4x plus 3x. It's not going to matter, all right? But just keep in mind, those are replacing the 7x. And it's not just plus 4 and plus 3. We got to have the x as well. Okay, well, our next step in this process after, we figured out, okay, what multiplies to a times c adds to b, we replace them in for that middle term, that b of x. What we're now going to do is we're going to kind of separate these 4 terms into pairings. So I'm going to group the first 2 together and I'm going to group the last 2 together. My goal is to figure out what is the greatest common factor out of my 2 terms that I'm sectioning together. Okay, all right, so let's start looking at this. Greatest common factor of 2x squared plus 4x. Well, I can definitely divide out at 2. I can't divide out any number higher, so I have 2 I'm dividing out. I can also divide an x out of both of those. Got it. Okay, that's looking good. All right, so once I do that, I got to say, what do I have left? What is left after I divide those out? Well, I have x, and then I have 2. We're going to do the same thing for the last 2 terms as well. We'll add a 3x and 6. What can I pull out? Well, I can pull out a 3. Now, remember, that's a positive 3, so I'm going to put a positive 3 there. I can't pull out a variable at all because it's only in the first term out of the pairing, so I'm going to be left with x plus 2. If you're looking at this and you're thinking, wait a minute, the terms I wrote in yellow, they're the exact same. Yes, that's the purpose behind this, because what we're going to relate back to is that warm-up problem we did. If we go back to the warm-up problem, let's start to compare some of the steps with each other before we get to that final step. We started off with our trinomial. That's kind of what we ended up with down here. We decided to break up that middle term of b of x into 2 pieces. Hey, look at that. That's the same right there. Next, we decided to kind of pair up each of the 4 terms. We pulled out a greatest common factor of those. Hey, that looks like this step. It's kind of like we're doing the distributive property in reverse. So look at that last step of our distributive property. What we did was we wrote down one of the repeated binomials. So in our problem, we're going to write down one of them, one of the yellow binomials. And then we took the greatest common factors that are out front and they were in the other binomial. So we're going to take the 2x and the 3 and we're going to put them as the other binomial. And voila, look at this. We were able to take our trinomial and we were able to work our way down, which essentially, like I said, is doing the reverse of what we did before. We were able to factor, and that's our answer. Like I said, if you wanted to double check this factoring by multiplying, I mean, we kind of already did the distributive property ahead of time to show that, but that's one way to do that. Now, to kind of help us on out figuring out the pattern, since we do have to use, that organizer to figure out what multiplies to a times c but adds to b, there is a little bit of a math tip down here. It says the factors of c will both have the same sign if c is greater than 0. If b is less than 0, both factors will be negative. But if b is greater than 0, both factors will be positive. So if that kind of helps you out, if not, no worries. We're still going to practice more with grouping. Let's continue on to example B. All right, so we're going to factor 3x squared plus 8x minus 11. And again, we're not going to do guess and check method. No way, Jose. We're going to end up doing grouping. So let's go ahead in the margin. Let's write down example B. And let's try this kind of using the method that we had before. You can look back at your notes to kind of help us figure it out. Okay, so again, we have this graphic organizer. We're going to multiply a times c, so that's negative 33, and we're going to see what adds to b. Okay, so what multiplies to negative 33 adds to 8. Okay, well, there's not many things that multiply to negative 33. Really, it's a combination of what? 1 and 33 or 3 and 10, and then, obviously looking at our positives and negatives, we know they have to multiply to a negative, so one of them has to be negative, and the other one will be positive. But then it adds to a positive, so we know our positive number has to be bigger, so we end up with -3 and 11. Now we're going to use those, the -3 and 11, they're going to replace the 8x. Now, not just -3 and 11, but -3x and 11x. So our first and our last term stay the same. We replace the 8x with -3x and 11x. Now, order of these actually doesn't really matter. Like I said before, I could flip them around, turn them each way, but you kind of want to be strategic about where you put it. I'm seeing kind of the 3's already involved with each other, and I'm seeing the 11's involved with each other, because I know my next step is going to be figuring out, okay, the greatest common factor of our two groupings of terms. So that's why I specifically put the -3x before the 11x here. Again, you could do it either way, but it's your choice. All right, so let's group these together. I think you kind of see why we're doing grouping, or why it's called grouping. Got it? Okay, so let's go ahead and pull out a greatest common factor out of the first two terms. And that's going to be 3x. And since we're dividing it out, we got to figure out what's left. Well, that's going to be x. Now, this isn't 0. Think of when you divide something by itself, you're left with 1. So we're subtracting 1. Let's do it for the second pairings. Okay, we have a positive 11 we're dividing out, so we're left with x minus 1. Again, looking at how we approach this, right? Like the problem above, we only wrote down one of the repeated binomials, and then we took the greatest common factors of the other, boom, and we put them together. So we're going to do the same thing here. Only write down one of the repeated binomials, and then we can write down the greatest common factors of the other. Like I said, it doesn't matter the order of either of those that you put first, but that's going to be your final answer. 3x plus 11 times x minus 1. They ended up getting the same result, but like I said, we don't want to use guess and check. That takes forever and doesn't necessarily guarantee an answer.